Welcome back. In this video we're going to talk about functions a little bit more. We're going to talk specifically about composition of a function, and then we're also going to talk about taking functions that are in the composition format, so f of g of x format, and we're going to separate them out. What I refer to as decomposition of a function. That's a very important concept that we're going to be using when we do derivatives and chain rule a little bit later on in the semester. So composition of a function, remember, is f of g of x. And you can write it that way. It's also the same as f and then a small open circle g of x. And those are read the same way. So f of g of x or f of g of x, they mean the same thing. We're going to look at it. Let me look at an example of composition of a function. And the tricky part of this is sometimes we look at the domain of this as well. And domain does get a little bit confusing. So let's let f of x be x over x minus 2. And let's let g of x be 3 over x. So then f of g of x is 3 over x divided by 3 over x minus 2. And then I would simplify this, so on the denominator, x is my common denominator, so the numerator stays as 3 over x. The denominator becomes 3 minus 2x over x. And then to finish this problem off, to simplify it, we will multiply by the reciprocal of that denominator. So I have 3 over x times x over 3 minus 2x. The x's will cancel on the diagonal, and I end up with 3 over 3 minus 2x. So then we have to consider the domain of the function. And the domain of the function, when we take a look at this, is first of all, with our domain, we have two restrictions. The number one restriction is that the first of all is that what you end up with cannot be division by 0. So 3 minus 2x cannot be 0. So the domain is going to be all real numbers except x cannot be 3 halves. And then also I can't plug in anything that's undefined. We kind of lose that one in the process. So in this particular case, whatever would make g of x undefined, because that's the one that I plugged in. So x can also not be 0 because that's the one that I plugged in, it's undefined. Notice that I did not include 2. 2 is not a restriction on this domain. What happens is that you can't, 3 over x cannot equal 2. And if 3 over x does not equal 2, then x cannot be 3 halves. And you can't be plugging in something that's undefined, and you can't what you're plugging in can't make your second function undefined. Okay. The second concept I want to talk to you about is the decomposition of a function. And with decomposition of a function, we're talking about something like this. If I were to say, well, h of x equals the square root of x squared plus 1. We have an inside function, which is the x squared plus 1, and we have an outside function, which is the square root. We need to be able to rewrite this using what we call our little substitution, sometimes trig, sometimes not, sorry, but using substitution. And with that substitution, what happens is the book does this a little bit differently, and their directions are a little bit different, but for our purposes, and it's really helpful to use the letter u. And you want u to be g of x, or that inside function. So I'm going to let u be x squared plus 1. And then I'm going to rewrite h in terms of u. So then h of u is the square root of u. And if you put those back together, you would get that. You would get the original relationship. Oftentimes we use y, like if I have something like, let's say y equals 2x plus 3 to the 25th power, then when I go to do the decomposition on this one, the u part of it is the 2x plus 3, and then y is u to the 25th. This is the most common format you're going to find in these decomposition types of problems. This is very important for when we get to chain rule with our derivative a little bit later on in the semester, and you'll get it. This is not a hard concept. This is an easy one, but it is very, very important down the road. So now you have enough information to do the next assignment.